Hello everyone. Next section we're going to cover is going to be defrost, and a really good resource for you other than the PowerPoint that's on Canvas. Really good resource is going to be your textbook, and that's Defrost Section 5, Unit 25, and I believe that it starts on page 643. So that'd be a really good resource for you to go read before you start into this section. It'll be the last section that we get to cover this semester. This week. Friday will be the last day that you'll be able to turn anything in. So you need to really keep up with these lessons through this week. Okay, so defrost. Why defrost? Why defrost? Well, evaporators, when we have evaporators that are running less than 32 degrees Fahrenheit. Anytime 32 degrees should tell you that ice is going to form at 32 degrees or below. So if we have an evaporator on a refrigeration system or a heat pump, a reach-in cooler, anything with an evaporator that has refrigerant flowing through it that's colder than 32 degrees, ice is going to form on it. Ice forms, and then ice equals low heat exchange. Why? Because we want our evaporator to be made out of conductive materials like copper and aluminum, and now if we put a ½ inch of ice on them and blow air over it, our efficiency drops. So defrost, we have defrost to keep our efficiency up. Ice on the evaporator reflects in low efficiency. We have to get rid of the ice. So we have to go through periods of time where we go into defrost. Okay? And when is that? Anytime we have evaporators less than 32 degrees. The colder it goes, the colder the evaporator goes, usually the more we're going to have to defrost. Now, there are several different types of defrost that we're going to talk about. One of them I don't even have wrote up here. I will talk about briefly, and that's called off-cycle defrost. What that is just the unit cycling on and off on its own. What we do is we leave the evaporator fan running even though the compressor's off, and this would be like pop boxes where the product is just 36, 38 degrees Fahrenheit, where the box temperature is warmer than ice, warmer than 32 degrees. We can defrost on our own in the off cycle. Okay, and then defrost types we can then break down into a few categories. We have time. And what this means is the first time is time takes us in or initiates the starting of defrost, and then time takes us out. So it's very simple. We have a timer motor, and in normal operation, we use a set of normally closed contacts to bring on our our refrigeration system. And then time puts us in defrost, and which would open this contact, kill the unit, and then close this contact simultaneously and bring on some defrost heaters or energizer reversing valve, something like that, to use hot gas defrost. So this is a very typical defrost clock. In the next video that I make is going to be ohming out defrost clocks, and we'll break this down even more. So time takes us in, and then time takes us out. The second type is going to be time temperature time. Once again, time takes us in. Time clock brings us in to defrost. And then temperature, in conjunction with a termination solenoid, which we will talk about in a little bit, we're in defrost, and then if the evaporator itself is able to get up to 40 degrees, that would mean no more ice. And so we would use a termination temperature control wired in series with a termination solenoid, that if the evaporator and the sensing bulb for this TC would literally be right on the evaporator. It would be submerged in there. And if we got up to 40 degrees, this temperature control would close, energize our termination solenoid, which would take us out of defrost. So time puts us in, and then temperature takes us out. And then if it lasts too long, we have a fail-safe of usually 40 minutes. Time would be our last resort, taking us out. Time in, first out would be temperature. If that takes too long, time takes us out. And then the last, the next one, time in, pressure would take us out. So if we start heating up the evaporator, the pressure on the low side would start going up in conjunction with the temperature. Temperature and pressure have a relationship. We've been learning that since first semester. And so instead of having a termination temperature control here, we would have a termination low pressure control, still corresponding to 40 degrees Fahrenheit. If our low side pressure got up to 40 degree pressure to temperature relationship, the TC would close, which would energize the termination solenoid, which would take us out of defrost. And then the last type is, they usually use solid state boards, and this would be on very advanced type of refrigeration systems, demand defrost. And what this is, and it's the most efficient, you make a note on that definitely, that demand defrost is the best, because something demands us to go into defrost. It keeps track of how much ice is on the evaporator. It only goes into defrost when we have to go into defrost. So each one of these, time dictates, hey, it's time to go into defrost. Whether you need it or not, you're going into defrost. Demand defrost uses either pressure or temperature that tells us we need defrost, let's go into defrost, and then the same thing, temperature or pressure will say, okay, all the ice is off, let's go out of defrost. Like I said, usually a solid state control board will do this. You will learn more about those in residential and commercial refrigeration, and in heat pumps and Capstone, you'll learn more about demand defrost. Okay, so 3 types: time in, time out, time in, temperature out, fail-safe time out. Time in, pressure out with a fail-safe of 40 minutes out. So let's look at a very, very traditional time clock here. This is a Paragon Defrost clock. Okay, and looking at the clock itself, you can see on the front you have a dial, and this is the hours in the day. This is a 24-hour clock. This would be the nighttime hours, and these would be the daytime hours. And just like any clock, you would have to set it. Right now it is 9 o'clock, and so that's AM. We would come over here to 9 o'clock, and what I'm looking at is right here, the time dial. Put it right at 9 o'clock. Okay, now I've talked about a fail-safe on the time, and it's usually set at 40 minutes. Right here is a little push-button tab. I can push down on this arrow and move this, and this would be the fail-safe, how many minutes it would actually stay in the defrost. And it locked up right there. But that should be around 40 minutes. Okay, right here. Okay, now these also have the designation pins. What I mean by designation pins is it designates the period of time when we need to go into defrost. And we can set that whenever we want to. We can take these little pins out. Usually they're in a carrying case right here. We can take this out and screw it in to the time that we want it to go in defrost. If we wanted to go in defrost at 10 a.m., we could screw a pin in there. And then as this clock sits there and turns, it would come to that pin and put us in defrost. Now, you can manually go into defrost by turning this, and it's very important that you only turn it one direction, okay? And I'll turn it around here, and you can kind of hear when it goes into defrost. You'll see this cam start to move right there, and it's going to click, a big click. Bam, it's in defrost. And then if I turn it a little bit more, it's going to click again, and it's out of defrost. Okay, now, this Paragon clock, this is an older style. I really like these. These were very durable. You can actually see the contacts positions, and they have them drawn up here. So between this terminal and this terminal is a set of normally closed, set of normally open, set of normally open, set of normally opens. So this type of clock right here would be used very commonly on three-phase heaters. And right here, the Z terminal, between here and here, we have a termination solenoid. Now you can see on the back of this, right here, the termination solenoid. And the termination solenoid, once again, what it does, let me put it in defrost. We're in defrost, and when something energizes this little solenoid, it pulls down and takes us out of defrost. Here is our clock motor right here. So if you're out in the field, you can take these out. These defrost clocks, you can take them apart and look at the components if need be, and know where what component is wired to. But it is a skill that we're going to learn, how to ohm these time clocks out. Okay, I'll say this again in the next video, but the timer motor has the highest resistance out of everything that you ohm out. If you have a termination solenoid in it, this will be the next highest. So this one would be like 800 ohms. This one would be like 400 ohms. Okay, the timer motor is always the highest resistance, and the termination solenoid is the next highest resistance. Okay, all timer motors will have a set of normally opens for defrost, and a set of normally closed for normal operation. Now you can see how I have little circles here as my terminal points. Okay? Now it is most common to see a common point like this right here. So if this was 2 would be common between here and here and here. That's real common to see that, but it's not a must. You could ohm out defrost clocks where you would literally have independent sets of contacts and the timer motor by itself. But usually there is a common point between one side of the timer motor and all your contacts. So what do all time clocks have in common? All time clocks have a timer motor, a set of normally closed, and at least one set of normally opens. We just seen a defrost clock that had 3 sets of normally opens. So you can see 1, 2, 3 sets of normally opens, and there are times where you see a couple of different sets of normally closed. Okay, but they all have a timer motor and at least some normally closed and some normally opens. Now, I have some arrows drawn here. Not all time clocks have a built-in termination solenoid. Some time clocks, if it's a simple time-in, time-out clock, it's only going to have a timer motor, a normally closed, and a normally open. If it's designed for time, temperature time, it's going to have a built-in termination solenoid. Okay? Now, time pressure time is a special clock. It actually is going to have a set of bellows on the bottom of it and a capillary tube that goes and connects to the low side. So I have it drawn here to a low pressure control, but this low pressure control is built in as the termination solenoid. So instead of having a termination solenoid, this pressure control is going to be what terminates defrost, the pressure control itself. Okay, so you need to do some studying before you go into the next video on ohming out clocks. I'll have an assignment over ohming out some defrost clocks. I will probably have a quiz over this particular video, but you need to go in and read your book. You need to look at the PowerPoint, study it very carefully, take notes on this video through this week before our final test, which is only going to be over defrost. So this week needs to be designated for defrost. Okay, have a good day.